Hey, chums of Examsnet. Welcome to the question series of Examsnet. Students, you must have explored our website www.examsnet.com. This site is a great place for you to practice all your entrance exam question papers because all the papers with their detailed PDF solutions are available there. For a better preparation, must download our app. The link is available in the description box. So students, today I'll be solving JEE Main's 30 Jan. Shift 2, that's your evening paper, 30 Jan 2024. Your evening paper. I'll be solving mathematical part in this particular video. So let's start with the paper of very best of luck. Question number 1. Consider the system of linear equations. This, and this, where lambda and mu belongs to the real numbers. Which of the following statement is not correct? Number 1, system has a finite number of solutions for lambda is equal to 1 and mu is equal to 3. Inconsistent for this, lambda is equal to 1, mu not equal to 3, consistent for this, and unique solution for this. Let's solve this, then we definitely will get an idea. So if I write these system of linear equations in the matrix form, this will be 1, 1, 1, 1, 2 lambda square and 1, 3 lambda. Yeah. So this is equal to 0 for infinite solutions. So I'm just checking for the solution. So let's put that to 0 and then I'll get to the value of lambda for which we will have infinite solutions. This will be, let's take the determinant 2 lambda minus 3 lambda square minus 1 into lambda minus lambda square plus 1. You have 3 minus 2. This is equal to 0. You have 2 lambda minus 3 lambda square minus lambda plus lambda square plus 1 is equal to 0, or you will have minus 2 lambda square plus lambda plus 1 is equal to 0. You will have lambda square minus lambda minus 1 is equal to 0. So 2 lambda square minus 2 lambda plus lambda minus 1 is equal to 0. 2 lambda into lambda minus 1 plus 1 into lambda minus 1 is equal to this. 2 lambda minus plus 1 is equal to 0. Lambda minus 1 is equal to 0. That means I have two values for lambda. Lambda may be equal to minus 1 by 2 or it may be equal to 1. See, all the options it's talking about value for lambda is equal to 1. Let's check with that only. If I put the value of lambda is equal to 1 and solve for x. Now, in that case, what will the determinant look like? This will be 1, 1, 5. See, I'm eliminating the x. So 1, 1, 5. 2 lambda square 9. 3 lambda and mu. 2 lambda square 9 and 3 lambda and mu. If I put the, see, everything is talking about lambda is mu is equal to 13. So let's put lambda as 1. See, for lambda as 1 and minus 1 by 2, you will have infinite solutions. Remember this thing. Okay. If I put lambda is equal to 1 and mu is equal to 13, this determinant will be 1, 1, 5, 2, 1, 9, 3, 1, 13. Let's find out the determinant now. This will be 1 into 13 minus 9 minus 1 into 26 minus 27 plus 5 into 2 minus 3. So this will give me 4 plus 1 minus 5. That's equal to 0. So that means if I take lambda is 1, mu is equal to 13, I will have infinite solutions. So if lambda is not equal to 1, you will have a unique solution. And for no solution, lambda will be equal to 1. And mu will be equal to 13. Not equal to 13 for no solution. Okay. See, if both are equal to, like, lambda is equal to 1, mu is equal to 13, you will have infinite solutions. If lambda is not equal to 1, that means you will have unique, one solution. If lambda is equal to 1, that means infinite solutions, but mu is not equal to 13, that means there will be no solution for that. So that means we have First option, system of infinite solutions for lambda is equal to 1 and mu is equal to 13 as the right answer to the question. Hope you're clear with this. Let's move to the next question number 2. For alpha and beta belonging to 0 to lying in the interval 0 to pi by 2, let's write down the equation by the side. You have 3 sine alpha plus beta is equal to 2 sine alpha minus beta. So sine alpha plus beta upon sine alpha minus beta is equal to 2 by 3. If you go on solving like usually what we do, it will be lengthy question. What I will do, because I have to reach tan alpha and tan beta, I want to separate both of them. So let's do with a very small thing, easier one. I'll be applying componendo and dividendo. You know this, right? Yeah. So this will be sine alpha plus beta plus sine alpha minus beta divided by sine alpha plus beta minus this. This will be 2 plus 3 upon 2 minus 3. Or this is sine A plus B plus sine A minus B. This will give me 2 sine alpha cos beta, 2 sine beta cos alpha. This is equal to minus 5. So this gives me 2 will cancel. Tangent of alpha upon tangent of beta is equal to minus 5, or you have tangent alpha is equal to minus 5 into tangent beta. Now, according to the question, you have tangent alpha is equal to k into tangent beta. That means k is equal to 5. So minus 5. You have option B as the right answer. Hope you're clear with this. Let's move to the next question. Question number 3, let A be the point alpha comma 0, B be the point 0 comma beta, be the point on this line. Let P divide the line segment AB internally in the ratio 7:3. Again, let this is the directrix for this ellipse and the corresponding focus be S. If from S the perpendicular on the x-axis through P, then what is the length of the latest rectum of E? So question is very lengthy. You need to understand you are given 2 sections of this question are there. First is like this half. You are having A and B 2 points which are lying on this line such that P is dividing AB line in the ratio 7:3. So from all of this first line, what you will get is the point P. Now this point P is falling on this ellipse, right? This is the equation of the ellipse and this is the equation of the directrix you given to you. These things are only given to you. For ellipse, you are given what? You are given the directrix, you are given the equation. Actually, this is the general equation of the ellipse, so no use. And you are given this point P. Basically, you are given these 2 things for the ellipse and you have to find out the latest rectum. It is given by 2b square upon a. So that means you need to know the value of b and a to find out the value of your length of the latest rectum. All right. Let's start. So I'll pick up the first section. In that, I'll be finding first the coordinates of A and B. This is the line 5x plus 7y is equal to 50. So for the coordinates of A, you have y is equal to 0. That gives you 5x is equal to 50. Or x is equal to 10. Here y is equal to 0. And the second one, so this is your point. This is y is equal to 0, right? So A is the point 10 comma 0. Now for the point B, you have x is equal to 0. So y will be equal to 50 upon 7 for x is equal to 0. The point B will be equal to 0 comma 50 by 7. Okay, now it's given that this is the line AB now. These are the coordinates. There is a point P which divides a line in the ratio 7:3. Let's find out the coordinates of P. Now the P will be given the coordinates as 7 into 0. That's 0. 3 into 10, that's 30 upon 7 plus 3, comma 7 into 50 upon 7 plus 3 into 0 upon 10. So these coordinates will be 3, comma 5. This is your P. Now, hope you're clear till here. Now this is your ellipse. This is your directrix. This is, what is the equation of the directrix? 3x minus 25 is equal to 0. So this gives me x is equal to 25 upon 3. Okay, fine. So this is, let's say this is the focus. It's given that this is S. Now it's given in the question. Read this one carefully. Corresponding focus is if from S perpendicular on the x-axis through P is passing through P. So that means if I drop a perpendicular from this on the x-axis from S, it will pass through P. The point of P was having the coordinates as 3 and 5. This is your focus, which is having AE as the coordinates, right? Okay. So one thing, see, AE will be equal to 3. And this is equation of the directrix. Directrix is always given as x is equal to a upon e. So here x is equal to a upon e. That means you have this. A upon e is equal to 25 upon 3. And from here you have AE is equal to 3, right? Let's fill in. Let's use this. A upon E is equal to 25 upon A into E. This gives me A square is equal to 25, or you will have A's value as 5. And if you get the value of A as 5, let's find out the value of B. You know the centricity. You have AE as 3, so E will be given by 3 by 5. And the centricity is 1 minus b square upon a square under the root. So this is 3 by 5 square is equal to 1 minus b square. A square is 25. This gives me b square upon 25 is equal to 1 minus 9 upon 25, or this will be 4 upon 25. So you have b square upon 25 is equal to 4 upon 25. That gives me b's value as 2. I got the value of b. Give me a minute. This was 16. So B will be 4, right? Okay, so what do you need to find out? The latest rectum, we already talked about the latest rectum. It's given by 2b square upon A. So I have A as 5, B as 4. I have the latest rectum as this 2b square upon A. This will give me 32. So this is the answer to the question, 32 by 5. This option D. Hope you're clear with this. Let's move to the next question, number 4. It says now a vector problem before us. It says let A be this vector, alpha, beta, they are the real numbers. Be a vector B such that the angle between A and B is pi by 4 and the modulus, the magnitude of the B vector is equal to 6. Dot product of the two vectors is 3 root 2. You have to find out the value for this expression. Okay. You have the dot product of the two vectors to be 3 root 2. What is dot product? Magnitude of A, magnitude of B, cos of angle between them is equal to this. You are given that the angle between them is pi by 4. So magnitude of B square is given to you. I don't know about A. So let's write down this is A. B will be root 6. B's magnitude, because this is B square is equal to 6. Cos of pi by 4 is equal to 3 root 2. A into root 6 into 1 root 2 is equal to this. Okay, so you will have magnitude of A vector is equal to 3 root 2 into root 2 upon root 6. This will be 6 upon root 6, which will be equal to root 6. Right, and this is your A vector. Let's find out the magnitude for A. The A vector is equal to I plus alpha j beta k. So the magnitude of A vector will be equal to root of 1 square plus alpha squared plus beta square. So that means from here, this is equal to this. That means root 6 is equal to root 1 plus alpha square plus beta square. Right? Now taking square on both sides, you will have 6 is equal to 1 plus alpha square plus beta square, or you will have alpha square plus beta square is equal to 5. Now let's go to what we had to find out was this thing. Alpha square plus beta square into the magnitude of A cross B whole square. Let's go. So you have to find out magnitude of alpha square plus beta square cross product of A and B whole square, the magnitude of it whole square. This came out to be 5, we just saw. And let's go for this. This will be equal to alpha, this is A cross B, this is the magnitude of A. This is square, right? So I'll write to square over here into magnitude of B square into sine square of angle between them. So this is equal to 5 into, this came out to be 6, and the magnitude of B was, okay, it's 6. And the sine square of pi by 4, this is equal to 1 by 2. So this will give me 3, 15, 90. Is the answer to the question. Option A. This is the correct answer to the question. Hope you're clear with this. Let's move to the next question, number 5. It says let fx be equal to x plus 3 whole square, x minus 2 cube, x belonging to this interval minus 4 to 4, m and small m are the maximum and the minimum values of f respectively in minus 4 to 4. Then the value of capital M minus small m is equal to. So you have fx as x plus 3, this x minus 2 whole cube for all x belonging to this interval. So let's find out the derivative because we are concerned about the maximum and the minimum values of fx. So f dash x will be given by, let's write this first function into derivative of second plus second function into derivative of first. So this is going to be 3. I'll take some things common. I'll take x plus 3x minus 2 whole square common. So this will be 3x plus 3 minus 2 plus 2 x minus 2. X plus 3, x minus 2 whole square. This will be 3x plus 9 plus 2x minus 4. This will be x plus 3, x minus 2 whole square, 5x plus 5, or this will be, I'm taking 5 outside, x minus 2 square, x plus 1, x plus 3. This is your f dash x. Now the sign variation of this derivative, this first derivative on the given interval x belonging to minus 4 to 4 is from here, this is minus 4. This is your line till 4. This is minus 3, minus 1, 0, 1, 2, and 3. So from this side, this negative, according to this function, when it lies positive in this interval, negative in this interval, and from here it will go on to be positive, positive only. Okay. So by the first derivative test, first derivative test, points of local minima are x is equal to minus this and this, minus 1, minus 4, and minus 1. So f of minus 4, this will be, this was your function. On filling in x is equal to minus 4 in this function, you will get f of minus 4 is equal to minus 216, and f, or sorry, f of minus 1, for filling in that function, it will give me minus 108. Now let's find out the point of local maximum. Okay, so point of the local maximum will be x is equal to minus 3 and x is equal to 4. So f of -3 on solving, you will get 0. F of 4 will be equal to 392. This is your m. According to the question, this is your m, and what was your small m? This is your small m. So you have a capital M minus m is equal to 392 minus of minus, this will be this plus. So you will have 608 as the right answer. Option C is the correct one. Hope you're clear with this. Let's move to the next question. Question number 6, let A and B be the two distinct positive real numbers and let 11th term of a GP whose first term is A, third term is B is equal to the pth term of another GP whose first term is A and the fifth term is B. Then what is the value of P? We're having two GPs over here. This is the first and let's say this is the second GP. So T1 in this case is equal to A and T1 dash, let's say this is the second GP. So I'm denoting it with some another name. That's equal to A again. And here you have the third term is B. That third term is given by A R square. This is equal to B. And over here, you have the fifth term is equal to B. So T5 dash is equal to B. That makes A R dash bar. R5 minus 1, that's 4, is equal to B. So R dash bar 4 is equal to B by A. All right. So also from here, you have R square is equal to B by A, or R will be given by plus minus root B by A. Okay. Now, this is the case for the second term, correct? And this is root B by A, or you have this as R square, correct? What I'll do is I'll fill in this equation B by A is equal to R square. So you have what do you need to find out? In the question, it is given that T11 is equal to TP dash. That means A into R power 10 is equal to A into R dash power P minus 1. Okay. Okay. So this is what I got for this. And let's find out the 11th term now. 11th term for not for this, sorry, and the one that this first series. So T11 is given by A into R power 10. So this is A into R square power 5, or A into B upon A power 5. And here was R dash is equal to the fourth power of this. So TP will be given by A into R dash power P minus 1. So this is equal to A into fourth root of B upon A raised to power P minus 1. They both are equal according to the question. According to question, T11 is equal to TP dash. So you have A into B raised to power B upon A raised to power 5 is equal to A into fourth root. That can be written as B upon A, P minus 1 power 4, divided by 4, right? A and A will cancel. And here was B upon A. So B upon A power 5 is equal to B upon A power P minus 1 upon 4. Bases are same, powers will be same. You have 21 as the value of P. All right, so this is the answer to the question 21. You have option C as the correct answer. Hope you're clear with this. Let's move to the next question, number 7. Now this says if x squared minus y squared plus 2hxy plus 2gx plus 2fy, this is the equation of a circle, is the locus of a point which moves in such a way that it's always equidistant from the lines this and this. Then the value for g plus c plus h minus f is equal to. Okay, so let's see. First of all, locus of the point which moves equidistant from these two given equation of the lines is given by x plus 2y plus 7 divided by the root of 1 square plus 2 square is equal to whole square is equal to second 2x minus y plus 8 divided by 2 square plus 1 square whole square. On simplifying this, you will get x square plus 4y square plus 49 plus 4xy plus 28y plus 14x divided by 5 is equal to, this will be 4x square y square 64 4xy 16y and 32x mine plus again 5. So they will cancel. You will have a minus 3x square 3y square plus 4 plus 8xy. This will be 6 and 3 4. This will be 44y and this will be plus, wait, it was plus and plus over here. Okay, so 14 minus 32, this gives me 18 and plus 49 minus 64 15. That's equal to 0. Dividing both sides by 3 and minus 3 actually. You will get x square minus y square minus 8 by 3. Let's write it like this. xy plus this will be 18 by 3 x plus minus 44 by 3 y plus 5 is equal to 0. Now let's see the given equation of the line. This circle x square minus this is not the circle. Sorry, this is not the circle. X square minus y square is there now. This is 2hxy plus 2gx 2fy plus c is equal to 0. So comparing it, this, and so you have 2h is equal to minus 8 upon 3, 2g as 18 upon 3, and you have 2f as minus 44 upon 3. Okay. From here, you get the value of h as minus 4 upon 3, g is equal to minus 9 upon 3, that is equal to minus 3 only. Okay. It is not minus, it's positive only. So f will be equal to minus 22 upon 3 and your c is equal to 5. What you have to find out is g plus c plus f h. To find is g plus c plus h minus f. Let's fill in 3 plus 5 minus 4 by 3 plus this. Let's take the 3 LCM. You will have this is 8, 24 minus 4 plus 22. You will have, no, not 2. This will be 20 and 42 upon 3. That is 14. So 14 is the right answer to the question, option A. Hope you're clear with this. Let's move to the next question. Question number 8, let A and B be two vectors such that the magnitude of B vector is equal to 1 and the cross product of B and A, the magnitude of it is equal to 2. You have to find out the cross product of B and A minus B vector magnitude square. Okay, so very easy question actually. This is 1 and the magnitude of B cross A vector is equal to 2. You know one thing that the B cross A vector dot B vector is equal to B vector dot B vector cross A vector, and this is equal to 0. So now let's find out this. You have to find out determinant B cross A minus B magnitude square is equal to magnitude of B cross A square plus B's magnitude minus 2. This will give me B vector dot this, or you will say this like this. Okay, and we just saw that this is equal to 0 and this is equal to 2. So 2 square 4 plus 1, That's equal to 5. This makes option B to be the right answer. Hope you are clear with this. Let's move to the next question, number 9. Now, this is let y be is equal to fx be the thrice differentiable function in this interval minus 5, comma 5. Question number 9, let y is equal to fx be thrice differentiable function in minus 5 to 5 interval. Let the tangents to the curve y is equal to fx at these 2 points make an angle of pi by 6 and pi by 4 respectively with the positive x-axis. If this integral is equal to alpha plus root 3 beta, where alpha and beta are the integers, you have to find out the value of alpha plus beta. Okay, so you have the y is equal to fx. So its slope at the point 1 is taking an angle of pi by 6. So that means f dash x is 1 by root 3. Similarly, f dash x at 1, at the point 1, it is given that it is, wait, it is tangent pi by 6. Similarly, f dash 3, this is equal to tangent pi by 4, that's equal to 1. Now let's pick up this integral. You have 27 limits 1, 2, 3. F dash t square plus 1 into f double dash t dt. Now let's put f dash t is equal to some u. So let's find out the second derivative of it, differentiating both sides with respect to this with respect to u. You will have f double dash t into dt is equal to du. Now the limits will also change because you have f dash 1 is equal to 1 upon root 3. Also, you have f dash of 3 is equal to 1. So now this integral will become I is equal to 27 integral 1 by root 3 to 1 u square plus 1 du. So this is 27. This will be u cube upon 3 plus u limits this. Now let's put the limits. This will give you 1 upon 3, right? Okay, this cube will give me, let's write it like this. See, whenever anything confuses you, just leave, go with it. Fill in properly. Wait, this is 1, right? So it was supposed to be, first of all, 1 upon 3 plus 1. Now it will be minus. This will be cube, right? So 9 root 3, 9 root 3 minus this. So this is 27, 4 by 3. This will be, let's take the LCM, 9 root 3. And here will be 1, then it will be plus 9. This will be 27, 4 by 3 minus 10 upon 9 root 3. So again, the LCM, 27. This will be 9 into, let's keep it like this, right? This will be 9 root 3 only. Right. So here will be 3 root 3, which is 12 root 3 minus 10. Right. And this will cancel 3. So you will have 36 root 3 minus 30 upon root 3, which is 36 minus 10 root 3. Right. So let's compare it with the given one. You are given that this is equal to alpha plus beta root 3. So this is equivalent to alpha plus beta root 3. This gives me alpha is 36 and beta is equal to minus 10. You have to find out alpha plus beta, which is 26. So this is the answer to the question. Option B stands to be the right answer. Hope you're clear with this. Let's move to the next question, number 10. Let P be the point on this hyperbola in the first quadrant such that area of the triangle formed by P and the two foci of the hyperbola is this 2 root of 13. Then the square of the distance of P from the origin is. So this is your hyperbola. This and this. This is your hyperbola, which is given by x squared upon 9 minus y squared upon 4 is equal to 1 in the first quadrant. There is a point, let's say this is the point P in the first quadrant, and the coordinates for P is, let's make it a bit more clear. Like, let's say it here. So this is your point P, which is having the coordinates alpha and beta. And these are the two foci. This is, let's say F1 and let's say F2. You know, the foci is AE0. This is minus AE0. And what is A in this case? From here, this is equal to 1. So A squared is equal to 9. That gives me A is equal to plus minus 3. And B squared is equal to 4. That gives me B is equal to plus minus 2. Okay, and now let's find out the centricity of the hyperbola. This is given by root of 1 plus b square upon a square. 1 plus 4 upon 9. This will be root 13. This is E, okay? So 13 upon 3. This is your centricity. So the two foci will have the coordinates. AE will be given by A into E will be root 13. Here was 3. What I'm doing? Here was 3. Okay, root and A is equal to 3. So A into E is this. So that means this will be root 13 comma 0, and this side will be minus root 13 comma 0. So I got the coordinates. Let's write down what things we got till now. A square was 9, B square was 4. E came out to be root 13 by 3. And the two foci were F1 was root 13 comma 0 and F2 minus root 13 comma 0. Now what I want is, let's check what was area of the triangle formed by P and the two foci. So this, let's wait. Okay. This is a triangle which is being formed. This. So area of this triangle, you are given in the question that this is equal to 2 root 13. This is the area of the triangle. What is the formula for area of the triangle? This is area of triangle. Let's say that was PF1, F2. This is given in the question to be 2 root 13. And this is half into base into height. What is base? It is a distance between the two foci, and h is your beta, right? This is your h. So this is your beta. This is equal to 2 root 13. So I have F1 and F2. Let's find out the distance between them. F1, F2 is given by, this will be 2 root 13 plus root 13. So this will be root 2 root 13 whole square plus 0. This will be 2 root 13 only. This is F1, F2. So this into 2 root 13 into beta is equal to this gives me beta as 2. So I got the value for beta. This is 2. Let's find out alpha. Anything given? No. All right. Anyways, this point alpha beta, this lies on this hyperbola. So I can find out alpha as well. Now, point P, which is alpha beta, which we just solved, that this is equivalent to alpha and beta was 2, lies on the hyperbola x square upon 9, y square upon 4 is equal to 1. So that means you have alpha square by 9 minus 4 upon 4 is equal to 1. So you will have alpha square is equal to 1 plus 1, 2 onto this. This will be equal to 18, right? So alpha will be equal to 3 root 2. Right. And now what I want is the distance, the square of the distance of P from the origin. So easy now. We got P, that was alpha beta, and that came out to be 3 root 2. And what was the beta? It was 2. And origin is having 0, 0, distance between, square of distance between them. Let so square of distance between them, this is 3 root 2 minus 0 plus 2 minus 0 whole square. This will be 9 into 2, 18 plus 4, that's 22. Right. So what is the answer? 22. Because I want the square of the distance. You have option C as the right answer. Hope you're clear with this. Let's move to the next question then. Question number 11, bag A contains 3 white and 7 red balls. This is a bag which is having 3 white, 7 red balls, a total of 10 balls. And there is a bag B which is containing 3 white and 2 red balls. That means a total of 5 balls. One bag is selected at random and a ball is drawn from it. The probability of drawing the ball from bag A if the ball drawn is white is. So here are three events basically. First one, event 1, E1, let's say that A bag is selected, and let's say E2 is that B bag is selected. E is the probability that a white ball is drawn. So what is the probability of event E1 to happen? There are 2 bags. So this is 1 by 2. Probability E2 is equal to 1 by 2. Probability that a white ball is drawn. See, there are 2 bags now, right? For the bag A, the probability that a white ball is drawn. So this will be given by that A bag is selected and you will draw a ball. So this is P E upon E1. This is equal to 3 white out of 10 balls. This is 3 by 10. Also, from the bag B, PE upon E2 is equal to, what was that? 3 upon 5. Right? Now, what do you have to find out? You have to find out probability that a white ball, of drawing a ball from bag A if the ball drawn is white. Okay, so you want a white ball from bag A, that is you want the probability event E1 upon E. This is given by probability E1 into probability E upon E1 divided by the sum of this. No, this is upon this plus probability E2 into probability E upon E2. Now you have everything, just fill in the values. PE1, that was 1 by 2. This is 1 by 2. So 1 by 2 into 3 by 10 divided by 1 by 2 into 3 by 10 plus 1 by 2 into 3 by 5. Let's solve this. You will have 3 upon 20. And here you will have, I'm taking the LCM directly. This is 20. And here was 3 plus this is 6. 3 upon 20, 9 upon 20, this is equal to 1 by 3. So this is the answer to the question. Option C stands to be the correct answer. Hope you're clear with this. Next is question number 12. Let f be a function from real to real numbers defined by this. If f of 0 is equal to -1, f dash log natural log 2 is equal to 21. Integral of this function is equal to 39 by 2. Then the value of a plus b plus c is, where is a plus a, b, c? Here you are having a, b, c. Okay. So let's start from here. You have fx is a e power 2x, b e power x, plus c into x. You are given that f0 is equal to -1. So f0, if I put this as 0, you have a into e power 0 plus b into e power 0 plus 0. So you have a plus b that is equal to -1 from here, right? Okay, so let's say this as equation 1. Now let's get back to here. Let's find out derivative of it. F dash x is equal to 2a e power 2x b e power x plus c. And okay, if I find out for this function, f dash for the natural log 2. This is given by 2a e power 2 into natural log 2 plus b into e power natural log 2 plus c. Let's solve. You have this as 2a e power natural log 2 power 2, that's 4. B e power natural log 2 plus c. So this will be 2a into 4, right? Yes. Yeah. So this will be 8a. And this will give me 4, no, 2b plus c. This was given to you as 21. So let's write it. You have 8a, 2b plus c is equal to 21. That's equation 2. And now you're also given integral of this function is equal to 39 by 2. Now you're also given integral of log e 4 fx. Let's write it here. Actually, this there is a bit of mistake. It is like this: natural log 4 fx minus cx dx. This is equal to limit natural 4. This is a e power 2x plus b e power x plus minus cx, like this plus cx and this minus cx, they will cancel. I'm not writing that. Dx only. Let's find out the integral of it. This will give me a e power 2x divided by 2 plus b e power x. Limits 0 to log of 4. Let's put the limits. You have a by 2 e power 2 log of 4 plus b e power log of 4 plus a by 2 e power minus a by 2 e power 0 and minus b into e power 0. This will give me a by 2 into 4 square, that will be 16, and this will be b 4b minus a by 2 minus b. So you have 8a minus a by 2 plus 3b. That's given to you as 39 by 2, right? So this is equal to 39 by 2. You will have here 15a by 2 plus 3b is equal to 39 by 2. Or you have 15a plus 6b is equal to 39. Let's say this is equation 3. So I have 3 equations now to get the value of a, b, and c. First one was this, and this is the second one, and this is the third one. Let's write down all the 3 equations first. You had a plus b is equal to minus 1. This was from 1. From 2, you had 8a plus 2b plus c is equal to 21. And from 3, you have 15a plus 6b is equal to 39. So this gives me a plus 1 is equal to minus b. Or simply I'll say a is equal to minus 1 minus b. Let's put this thing in this equation. So 15 minus 1 minus b plus 6b is equal to 39, or minus 15 minus 15b plus 6b is equal to 39, minus 9b is equal to 39 plus 15, which is 54. B is equal to minus 6. And if b is equal to minus 6, what will be a? It will be b is equal to minus 6. So this will be 5. Okay. So I got the value of a. This is 40. This will be minus 12 plus c is equal to 21. C will be equal to 21 minus 28. Or this is equal to minus 7. I got a, b, c. Now what I want is a plus b plus c modulus. This is 5 minus 7 minus this under the mod. So the answer to the question 13 minus this, you have 8. That makes D option to be the right choice. Hope you're clear. Let's move to the next question. Question number 13, let L1 be this factor where lambda belongs to real numbers, L2 be this factor where mu belongs to real numbers, and L3 be given by this factor where delta belongs to the real numbers. Be three such lines that L1 is perpendicular to L2, L3 is perpendicular to both L1 and L2. Then the point which lies on L3 is, what is L3? It is here, this is J cap. Okay, so you have L1, L2, and L3. L1 is given to you, oh, like this. This is L2, and here is your L3. All right. So you're given that L1 is perpendicular to L2. If they are perpendicular to each other, that means, wait, you're given L1 perpendicular to L2. So that means 3 into 1 minus 1, 2p plus, this is equal to 0, right? This gives me p is equal to 2p is equal to minus 2, or p is equal to minus 1. Also, you're given that L3 is perpendicular to L1. So that means L3, I told you this is this. So L into 1. This is L, m into minus 1 minus m plus 2n is equal to 0. Okay. Also, you are having L2 is perpendicular to L3. So that makes L2 is perpendicular to L3. 3L plus M plus NP. 3L plus M plus N into P is equal to 0. Or you have 3L plus M. P was equal to minus 1 minus N is equal to 0. This is what you have to find out. In the point which lies on L3 is, see, L3 line is given by delta Li cap, Mj cap, and K cap. So I need to find Lmn to answer the question. So let's check which of these points satisfies this equation. Let's see for the first one, minus 1, 7, and 4. Minus 1, 7, and 4. Let's write the second, minus 1, minus 7, and 4. C part, 1, 7, minus 4. And the D part, 1, minus 7, and 4. Okay, so this will make it minus 3 plus 7 plus 4. This is not equal to 0. So this is not the answer. This was 4 and this was minus n. There is a correction. I'm rewriting this line. So minus 3 plus 7 minus 4. This is equal to 0, of course. So this is the answer to the question. I don't need to check other options. We already don't have much of the time. So let's drop the question over here only. You'll check rest of the options will not satisfy this equation. Hope you're clear with this. Let's move to the next question, number 14. It says let a and b be the real constant such that the function f defined by fx is equal to this is differentiable on r. Then the value of this function integral minus 2 to 2 fx dx is equal to. Okay, so here you have, let's write down the function. Fx is equal to x square 3x plus a for x less than equal to 1, and bx plus 2 for x greater than 1. This is be differentiable on R. So that means if this is differentiable, so fx is continuous at x is equal to 1. What is f of 1? Limit x approaching 1 plus fx. I'll use this this would be 1 plus 3 plus a. Now this is because this is differentiable, this is continuous, so that means this both will be same. This will give me b plus 2. So you have minus a plus b is equal to 2. Let's say this is equation 1. Now let's differentiate this function. F dash x, this is equal to x squared. This will be 2x, 3x will give me 3 for x less than equal to 1, and this will be b for x greater than 1. Now, because we just saw that f is it's given that it's differentiable at x is equal to 1. Therefore, what is it? The value for this at x is equal to 1, it is 5. So that means b will be equal to 5. So now from equation 1, you had minus a plus b is equal to 2, minus a plus 5 is equal to 2, or you have a as 3. Therefore, let's go to the question back. You have to find out this. Let's go to find integral minus 2 to 2 fx dx is equal to minus 2. I'll break it up because it is the breaking point is x is equal to 1. So this is x squared plus a was this 3x plus 3 dx. From 1 to 2, this will be 5x plus 2 dx. This will give me x cube upon 3, 3x squared upon 2, 3x minus 1 to 2, plus 5x squared upon this plus 2x limits 1 to 2. So this will give me 1 upon 3, 3 upon 2 plus 3 minus of minus 8 upon 3 plus this will be 12 upon 2 plus minus 6 plus this will be 10, right, plus 4 minus 5 by 2 minus 2. Okay. Wait, let me check once. This will be minus 8 by 3. Yes, everything fine. So this will be, let's solve it. This will be 1 by 3 plus 8 by 3 plus 3 by 2 plus 12 by 2 plus 3. This was supposed to be minus 3 by 2. Now plus 3 plus 6, which is 9, plus, and this is 12 minus 5 by 2, or this will give me 3, and this will give me minus 9 by 2 plus 21 minus 5 by 2, 24 minus 7, that is equal to 17. So this is the answer to the question. Option D is the right answer. Hope you are clear with this. Let's move to the next question. Question number 15, let f be a function for all the real numbers except 0, 2 real numbers. Be a function satisfying this equation for all xy and fy not equal to 0, f dash 1 is equal to 2024. Then which of the following is true? You are having in the question f x upon y, this is equal to fx upon fy, differentiating both sides with respect to x, you will have f dash x upon y into 1 upon y is equal to 1 upon fy into f dash x. As y approaches x, you will have f dash 1 upon 1 into 1 upon x is equal to, this will be f dash of x upon f dash f of x, right? And you are having f of 1 is equal to 2024. This makes it 2024 into 1 by x is equal to f dash x upon fx, or you have 2024 into f dash x is fx is equal to x into f dash x. You have x into f dash x minus 2024 fx is equal to 0. That makes the first option to be the right answer. Hope you are clear with this. Next is question number 16. If there is a complex number, then the number of common roots of the equation this and this, the common roots to this equation is equal to what? So you're having two equations. First one is z bar 1985 plus z bar 100 plus 1 is equal to 0, and the second z cube 2z square plus 2z plus 1 is equal to 0. So let's factorize this. Z plus 1 is one of the factors. You can check. And second, this will be given by, let's do the division. Here is Z cube, 2Z square, 2Z plus 1. Here is Z plus 1. So this will give me, first of all, Z square, Z cube plus Z square minus minus. This will be Z square plus 2Z. Here will be plus Z. And Z square plus Z minus minus. This will be Z plus 1. So here you will have 1 plus 1. So this is the one. Z square plus Z plus 1 is equal to 0. So that makes Z can be equal to minus 1, or you will have Z square plus Z plus 1 is equal to 0. That makes the two more roots as omega and omega square. So that means Z can be equal to minus 1 omega or omega square. Omega is the cube root of unity. Now, see, if I put Z is equal to minus 1, it will not satisfy this equation. This will be minus 1 plus 1 minus 1 is not equal to 0. So Z cannot be taken as minus 1 because it is not satisfying the second equation, this one. So let's put then Z is equal to omega. This makes the first equation as omega power 1985, omega power 100 plus 1. See, you know omega is equal to, omega cube is equal to 1, and also 1 plus omega square is equal to 0. So this is, if I write in the multiple of 3, this will be, let's divide 1985 with 3. You will have 6 and 6 and 1. So remainder will be 2. So this will give me omega power 661 multiply. This will be, yes, plus 2 plus omega power 99 plus 1 plus 1. This will be omega power 661 into omega square, omega power 99 into omega plus 1. This is equal to 1 because this is a multiple of 3. And this will be omega square plus this, which is equal to 0. So that means omega and omega is a cube of, is a root for this equation. Now let's check for Z is equal to omega square. This will be omega square power 1985 plus omega square power 100 plus 1. This is omega power 3970, omega power 200 plus 1. So this will be 1. Again, this will be omega power 198 into omega square plus this will be omega power 1323 into omega. Okay. This will be 1 plus omega square plus this, that's equal to 0. So this is also a root for this equation. So that means this is having this equation Z power 1985 plus Z power 100 plus 1 is equal to 0, has omega and omega square as the roots. And already your equation Z cube plus 2Z square has 1 and omega and omega square as the roots. So how many common roots are there? 2 common roots. Right? Let's check. You have the option B as the right answer. Hope you are clear with this. Next is question number 17. Suppose 2 plus P, 2 minus alpha, alpha are the coefficient of the 4 consecutive terms in the expansion of 1 plus x raised to power n. Then the value for this expression is equal to. So you are having 2 minus P, 2 minus alpha, and alpha. They are the coefficient of the 4 consecutive terms in the expansion of 1 plus x raised to power n. So the binomial coefficients in the expansion of this is given by binomial coefficients. In expansion of 1 plus x bar, n is given by NCR, NCR plus 1, NCR plus 2, NCR plus 3. These are the four consecutive binomial coefficients in the expansion of the given term. So according to the question, this is this 2 minus p, this is p, this is 2 minus alpha and alpha. If I add both of them and add both of them, you will have a NCR plus NCR plus 1 is equal to 2. This is nothing but n plus 1, CR plus 1, this is equal to 2. Similarly here, NCR plus 2 plus NCR plus 3 is equal to 2. This is n plus 1 CR plus 3, that's equal to 2. If I see both of them, you get n plus 1 CR plus 1 is equal to n plus 1 CR plus 3. So that makes n plus 1 is equal to R plus 1, R plus 3. Or 2R plus 4. Or n is equal to 2R plus 3. So you have a 2R plus 4 CR plus 1 is equal to 2. If I'm using this equation, n plus 1 CR plus 1 is equal to 2. Now, no such R exists. No such R exists. Now, since 2 minus P, 2 minus alpha, alpha are all positive integers. Therefore, p is equal to 1, alpha is equal to 1. Now, what you had to find out was p square minus alpha square. Then it was plus 6 alpha plus 2p. This will be 1 minus 1 plus 6 plus 2, that's 8. So this is the right answer. Option C. Hope you're clear with this. Let's move to the next question, number 18. If the domain of the function fx is equal to log e power log e to x plus 3 plus cos in divided by this function plus cos inverse this function is alpha beta, then the value of 5 beta minus 4 alpha is equal to. Okay, so here you have, let's write down the function. You have fx log e 2x plus 3, 4x square plus x minus 3 plus cos inverse 2x minus 1 upon x plus 2. Clearly, this thing should be greater than 0 because this is a function of log 2x plus 3 upon 4x squared plus x minus 3. This should be positive. Let's factorize the denominator 2x plus 3. The two factors will be 4x minus 3, x plus 1. This should be greater than 0. See over here, if you have a 4x squared plus x minus 3, this will be this 4x minus 3x minus 3. So here will be 4 will be taken common, 4x. This will be 1 plus x, here minus 3, x plus 1. So the two factor 4x minus 3, x plus 1. Okay, now this should be greater than 0. So that means the breaking points are minus 3 by 2, minus 3 by 4, and minus 3 by 2, 3 by 4, and minus 1. This is minus 3 by 2, minus 1, and 3 by 4. We have to do plus, negative, plus, and negative. Therefore, x will belong to, this is closed, open. X belongs to minus 3 by 2 to minus 1 union 3 by 4 to infinity. Also, the second one, you know, cos theta lies between minus 1 and 1. So that means this lies between minus 1 and positive 1. So you have 2x minus 1 upon x plus 2 plus 1 greater than or equal to 0, or you have 2x minus 1 x upon x plus 2 minus 1 less than or equal to 0. This will give me 3x on solving 3x plus 1 upon x plus 2 greater than or equal to 0. And this will give me x minus 3 upon x plus 2 less than or equal to 0. Let's see how it changes. The two breaking point minus 1 by 3 and minus 2. Here will be positive, positive, and then negative. So here the 3 and minus 2. So this is 3 and this positive, positive, and negative. Therefore, x belong to minus infinity minus 2 union minus 1 by 3 to infinity. And from here, x belongs to minus 2 to 3 closed. Okay, so therefore, x belongs to, if I combine both of them, these two, this one and this one. So x belongs to 3 by 4 to 3. And this is equivalent to, according to the question, this is equivalent to alpha beta. So that means you have alpha and this is beta. What you had to find out was 5 beta minus 4 alpha. This 15 minus 4, that will be 15 minus 3, 12. So you have option B as the right answer. Hope you're clear with this. Now let's move to the next question, number 19. Let R be a function from real to real numbers defined by this equation, and G is, oh God, this is f of x. So there are 4 loops to the function. Then 18 integral of this given function is equal to, okay, this is your fx, x upon 1 power, x upon 1 plus x power 4, power 1 by 4. What will be f of x? This will be given by x upon 1 plus fx power 4 power 1 by 4. Let's open it up. Fx was equal to x upon 1 plus x power 4 whole power 1 by 4 divided by 1 plus x power 4 upon this raised to power 1 by 4. So you will have like this, and this denominators will cancel. You will have x upon 1 plus 2x raised to power 4 raised to power 1 by 4. Right? Similarly, you will check for f of x. That means 3 times this. This will be given by x upon 1 plus 2 power x power this whole divided by 1 plus this will be, this was okay, 2x power 4 upon 1 plus x power 4 raised to power this. Okay, so you will have x. Again, these things will cancel, and you will have 1 plus 3x power 4 power this. Notice one thing. Yes, I hope you have noticed it. So when I did f of x, here was f of x. This was coefficient of x in the denominator. Coefficient of x raised to power 4 was 1. When I have f of x, that means 2 times. I got a 2 over here. When I got f of x, I got a 3 over here. Similarly, you will solve f of x. This will give me x upon 1 plus 4x power 4 raised to power 1 by 4. Okay, now let's get to what we had to find out. This was equal to your gx. So this. Now to find was 18, 0 to limits this root of 2 root 5 x cube. This will be, yeah, x square into this. So this will be x cube into 1 plus x power 4 power 1 by 4 dx. Let's put 1 plus 4 x power 4 is equal to this. This will give me 16 x power 3. This is equal to 4t cube dt. Or now let's get to this expression, this integral. Let's say this is equal to I. So I is equal to 18 upon 4. This will be, the limits will be changed. See, when you have this is when x is equal to 0, t will be 1, and when x will be root 2 root 5, it will be, the t will give you on solving, this will be 2 and wait, 1 plus 4 into root 2 root power 5. This is equal to 1 plus 4 into this power 4. This is gonna give me 2 root 5 square. This will be 1 plus 4 into 5. That will be into 2 into 5. This will give me 81. So this was equal to t power 4. T power 4 is equal to 81. This will give me t as 3. Now the limits will be, the new limits will be when x is equal to this. This is equal to, so when x is equal to this, t will be equal to 3. Limits will change from 1 to 3. This will be given by t cube dt upon t. So this is equal to 9 by 2 t square. Okay. Integral 1 to 3. This will be t square dt, or this is equal to 9 by 2 t cube upon 3, limit 1 to 3. You will have 9 by 2. This will be 27 by 3 minus 1 by 3, 26 by 3. This will be 39. So 39 is the answer to the question. Option D. Hope you're clear. Question number 20, let R be this matrix be a non-zero 3 by 3 matrix where x sine theta is equal to y sine theta plus 2 by 3, z sine theta plus 4 pi by 3 not equal to 0. Theta lying between 0 to 2 pi. For a square matrix M, let the trace of M denote the sum of the diagonal entries of M. Then among the following statements, number 1, trace of R is equal to 0, and if trace of adjoint of R is equal to 0, then R has exactly one non-zero entry. So you are having this is equal to this is equal to z sine theta plus 4 pi by 3, and you are given that they are not equal to 0. So you can write down like y is equal to x sine theta upon this, and z is equal to x sine theta plus 4 pi by 3. Now let's find out the trace of M, which is the sum of the diagonal entries, that is x plus y plus z. This will give me x plus this plus this and x comma y comma z. This is not equal to 0. Also, sine theta plus 2 pi by 3, sine theta plus 4 pi by 3. This is equal to 0 for all theta belonging to the real numbers. So that means 1 upon x, 1 upon y, 1 upon z. The sum is equal to 0, which gives me LCM and xy, yz, zx is equal to 0. So this gives me xy plus yz plus zx is equal to 0. So that means if I say trace of M matrix, this is x plus y plus z. If I'm taking x plus y plus z is equal to 0 and x, y, yz and zx is equal to 0, this only implies that x is equal to y is equal to z is equal to 0, which is not given over here. It's given that this is not equal to 0. This is a non-zero matrix. It's given over here. That means the first statement is incorrect. Now the second one, if trace of adjoint of R is equal to 0, then R has exactly one solution. So that was your R matrix. Now the second statement. First one is wrong. R matrix is X 0, 0, 0, Y 0, 0, 0, and Z. What will be the adjoint of R? See, this is a cofactors thing. C11, C12, C13, C21, 22, 23, C31, 32, 33. So this is first row, first column. I'm leaving this, so this will be YZ. And second row, okay, first row, second column first. This will be 0. On solving this, you will get this. XZ 0, 0, XY. I hope you know how to find out their joints, right? Similarly, if you will find out adjoint of R, this will come out to be x square y z 0, 0, 0, y square x z 0, 0, z square x y. So what will be the trace of it? Trace of adjoint of R. This will be the sum of the diagonal matrices. I'm taking x, y, z common. So this will be x plus y plus z. Now this is not equal to 0. Or if I take, according to the question, it's given that this is equal to 0. If I take this is equal to 0, then one thing we know from the previous statement 1 that this is not equal to 0. That means either of them, x or y or z, that may be equal to 0, right? And that's not also true. So that means the statement 2 is also wrong and 1 is also wrong. Both of them are incorrect. Option B is the right answer. Hope you're clear. Next is question number 21. It says let y is equal to yx be the curve lying in the first quadrant such that the area enclosed by this curve and the coordinate axis. Let's make the figure to understand this first. So this is your figure. This is y is equal to yx. This is the curve given to you. Look at the curve. This is the one. Curve given to you, and this is the equation of the line. This is the equation of the curve. This is your curve and the line. There are 2 points of intersection, this and this. Actually, this line is cutting the x-axis, y-axis at this point. Let's find out the coordinates first. Okay. So now the first thing you are given that the area enclosed by this line and the curve where and the coordinate axis where x, y is any point on the curve is given by this. So this is the area enclosed by the curve and the line and the coordinate axis. So this is actually forming this one. Wait. This particular triangle, right? This one. So now you have to find out this area. Not find out, we are given the area is equal to minus y square upon 2y dash x plus 1. You know, area of the rectangle, area of the triangle is given by half into base into height. So this is your base and this is your height. Right. For finding the base and the height, what I need is the point of intersection of the line with the coordinate axis. What is the equation of the line given to you? It is y minus y is equal to, for the simplification, y dash x. I will simply write it as y dash x minus x. These are the coordinates, x, y. And okay, for the point of intersection with the x-axis, when y is equal to 0, that is your x-axis, you will have a 0 minus y is equal to y dash x minus x, or minus y upon y dash plus x is equal to x. Now similarly, when x is equal to 0, that means I'm talking about the y-axis. In that case, you will have y minus y is equal to y dash 0 minus x, or I have to find out what this will be given by y minus x y dash. Correct. Yes. So now this is actually forming your base, and this is forming your height for the triangle. Area of the triangle is half into base into height. So this is equal to, you're given that the area is equal to what it is, minus y square upon 2y dash x minus y square upon 2y dash x. I'll simply write it as y dash only, plus 1 is equal to half into base. What was the base? This is minus y upon y dash, right? Minus y upon y dash plus x into, this is yeah, this one. Okay, so let's simplify this. You will have a minus 1 by 2 into y dash plus x by 2, right? Y minus xy dash. Let's open up. So you will have minus 1 by 2 into y square upon y dash plus 1 by 2 into xy plus xy upon 2 minus x square y dash upon 2. This is equal to minus y square upon 2 y dash plus 1. This and this will cancel out. You will have and adding both of them, you will get x y minus x square y dash upon 2 is equal to 1. Multiplying both sides by 2, you have 2xy minus x square y dash is equal to 2, or you have making y dash the subject of formula. You will have y dash is equal to 2 minus 2xy upon minus x square, or simplifying this, you will have 2 minus x square, 2 upon minus x square plus 2y upon x. All right. So let's simplify. You have I will write it as dy by dx plus minus 2 into y upon x is equal to this thing, right? Now, see, here you will have an integrating factor because this is of the form dy by dx plus some function of p into y is equal to qx. So integrating factor will be given by e power integral of p dx, which is here your px is equal to, what is your px? That is equal to minus 2 upon x. Integral of minus 2, I will write outside this. So this will be equal to e power minus 2 log of x. This is equal to 1 by x square. So your function becomes, let's solve it. You will have y into 1 by x square is equal to 2 by 3 minus over here and here into x power minus 3 plus c. Now you're given that y of 1 is equal to 1. That means when x is equal to 1, you have y is equal to 1. So this will give me 1 is equal to 2 by 3 plus c. This gives me c is equal to 1 by 3. Now this equation will become y upon x square is equal to 2 upon 3 x cube plus 1 upon 3. What you have to find out was 12 y2 is equal to. So y2, that means the value of y, 12y2, that means the value of y when x is equal to 2. This will give me y upon 4. Wait, this is, I will write it as y is equal to x square, 2 by 3, x cube plus 1 by 3. So this will give me x is equal to 2. This will be 3 into 8 plus 1 by 3. 12 into this 1 by 12 plus 1 by 3. 12 into 12 LCM, and here will be 5, right? Wait, I have, let me check once. This was y is equal to 2. Yeah, this was left. Sorry, x cubed. So this has to be multiplied by 4 as well. So this has to be multiplied by 4. This has to be multiplied by 4. So the answer will be 20. So this, the answer to the question is 20. Hope you are clear with this. Let's move to the next question. Question number 22. Let a line passing through the point -1, 2, 3 intersects this line at M and this line at N. Then the value of this expression is equal to. You're having two lines over here, right? So this is the first and the second line. Let's see. This is, let's say, first and the second line. This is L2 line and this is L1 line. And this is a point which is passing through this line -1, 2, 3. This is the point of intersection M, alpha, beta, and gamma. This is the point of intersection N, which is given by A, B, C. Now, see, what will be the coordinates of M over here? For the point of intersection M, alpha, beta, gamma. This will be given by, because this is the equation of the line. So this will be given by 3. Let's say this is equal to some, let's say this is equal to some gamma. Okay. Lambda, sorry. Gamma has already been used. I'll be using lambda. So this M will be equivalent to 3 lambda plus 1. And then will be 2 lambda plus 2 minus 2 lambda minus 1. Similarly, the endpoint, which is given by ABC, this will be given by, let's say this is equal to some t. So this will be given by -3t minus 2t plus 2. Then 4t plus 1. Now, let's say this is the point A, 1, 2, 3. At the point A, what will be the direction ratios of the line which is passing through this? Direction ratios of line passing through A. This will be given by this R. 3 lambda minus of -1, this will be +2. 2 lambda plus 2 minus 2. 2 lambda minus 2 lambda minus 1 minus 3. Minus 2 lambda minus 4. Minus 1 minus 3, yes. And or it will be given by, if I use this equation, this will be -3t minus 1 minus 2t 4t minus 2. So direction ratios of the line which is passing through this are this and this. This implies that 3 lambda upon 2 upon this is equal to 2 lambda upon minus 2t is equal to -2 lambda minus 4 upon 4t minus 2. So let's solve them to get the value of lambda and t. And using first of all these two, this will be -6 lambda t minus 4t is equal to -6 lambda t minus 2 lambda. They will cancel out. So you will have t is equal to 2t is equal to lambda. Let's solve these two then. You have 8 lambda t minus 4 lambda is equal to 4 lambda t plus 8t. This is 4 lambda t minus 4 lambda minus 8t is equal to 0, or lambda t minus lambda minus 2t is equal to 0. I had lambda is equal to 2t. So this will be 2t square minus 2t minus 2t is equal to 0. 2t square minus 4t is equal to 0. This gives me t cannot be equal to 0. That means t is equal to 2. If t is equal to 2, lambda will be equal to 4. I got the value of lambda and this. What were your coordinates of m be like? M had the coordinates 3 lambda plus 1, 2 lambda plus 2 minus 2 lambda minus 1. So the coordinates of M will be 13, 10 and minus 9. N had the coordinates as minus 3, minus 2 plus 2, 4t, 4t plus 1. So N will have the coordinates minus 8, minus 2 and 9. Right? So this was your alpha, beta, gamma, and this was your A, B, and C. You had to find out in the question was alpha, beta, and gamma divided by A plus B plus C whole square. So this is equal to 13, 10 minus 9 divided by minus 8 minus 2 plus 9 whole square. This will give me 14 square. Divided by 1, that's 196. So you have 196 as the answer to the question. Hope you're clear with this. Let's move to the next question. Question number 23. Consider two circles C1 and C2 given by these equations where alpha lies between 5 and 9. Let the angle between the two radii, one to each circle drawn from the point of intersection of C1 and C2 be sine inverse this angle. If the length of the common chord of C1 and C2 is beta, then what is the value for alpha beta whole square? You are given that sine theta. Let's say, let's have the figure to understand the problem clearly. So these are your two circles, and let's say this is the angle theta between them according to the question. Okay, and let's change the color. Okay. Okay. This was your theta. So what is you are saying sine inverse, the angle between them is given by sine inverse root 63 by 8. Let's say this is equal to the theta angle between them. So you will have sine theta as root of 63 upon 8. And what is cos theta equal to? Cos theta is given by R1 square plus R2 square minus the distance between the two centers that you can say this is equal to C1, C2 whole divided by 2R1 into R2. So cos theta here, what is R1? This is 25. So R is equal to 5 and this is 14. So R is equal to 4 for the second circle. You have R1 as 5 and R2 as 4. Okay. What is the, you are given that from here, the coordinates for the center are 0 and 0, and from here the coordinates for the center, this is C1, and from here the coordinates of the center are alpha and 0. So let's find out D also. D will be given by alpha minus 0 whole square plus 0 minus 0 whole square. That means D is equal to alpha. R1 we calculated is 5, R2 we calculated is 4. So this makes 25 plus 16 minus alpha square, here was D square, divided by 2 into 5 into this makes it 40. So this is your cos theta, and the sin theta we already have as root 63 by 8. Okay, from here, if you want to calculate cos theta, this will be given by 1 root of 1 minus sine square theta. This will be equal to 1 minus 63 upon 64, or this will be 1 by 8. So that means this equation is equal to 25 plus 16. This makes it 41 minus alpha square upon 40 is equal to 1 by 8 according to the question. or you have 41 minus alpha square is equal to 5, or alpha square is equal to 36. That gives you alpha's value as 6. Now, equation of common chord. We're subtracting the two circles, which is x square plus y square is equal to 25, and another one, x minus 6 whole square plus y square is equal to 16. This will be x square plus y square minus this is equal to 16 minus, no, 25 minus 16. So this will be y square and y square will cancel. X square minus x square minus 36 plus 12x is equal to, this will be 9. So this will cancel. You have 12x is equal to 45, or x is equal to 15 by 4. This is the equation of your common chord, this one. So that means your AM will be equal to, see here, this is equal to 15 by 4. So that means this point, if I look at over here, this point will be 15 by 4. That means your AM length is going to be 15 by 4. Simple as that. Okay. Now let's apply the Pythagoras theorem. I have AM, I know the value of AP, I can find out the value of PM. PM will be given by, so here PM will be given by, this is root of AP square minus AM square. This is AP was 5 square minus this is 15 by 4 whole square. This will give me 25 minus 225 upon 16, or on solving, let's say this is PM square for the time being. So PM will be given by, let's say, 25 into 16. This gives me 250 plus this will be 400, I think. Yeah, it will be 400. Just let me check. Yes. So 400 minus 225 upon 16. This gives me 5, 7, and 1 upon 16. So let it be like this only. What you need to find out is twice of PM. This is PM, right? So twice of PM will be given by, this is root of 175 upon 4 into 2. So this will be root of 175 upon 2. This was your PM. What was beta? Beta was the length of the common chord of the two circles is equal to beta. So length of the common chord came out to be this. Length of common chord, that is beta, is 175 under the root upon this. So alpha was equal to 6. You had to find out alpha beta raised to power 2. That was to find. So this is 6 into root 175 upon 2. This gives me 3. So this is the square will give me this whole square. It will give me 9 into 175, which is equal to 1575. So this is the answer to the question, 1575. Hope you are clear with this. Let's move to the next question, number 24. It says, question number 24, if alpha is given by this expression, summation k is equal to 0 till n, and the beta is given by summation k is equal to 0 till n minus 1, this expression, and if 5 alpha is equal to 6 beta, what is n equal to? So you are having alpha is equal to summation k is equal to 0 till n c k whole square upon k plus 1. Let's do one thing. I'm opening this. K is equal to 0, n nck upon k plus 1. Let's multiply numerator and denominator by n plus 1. So this expression now will be equal to summation, I'll be taking 1 upon n plus 1 outside, k is equal to 0, and till n, know one thing, that if I take n plus 1 upon k plus 1 into n c k, this is becomes equal to n plus 1 c k plus 1. So I can write it like this: n plus 1 c k plus 1 multiply n c n minus k. You know, nck is also equal to nc n minus k, right? So your alpha becomes equal to 1 upon n plus 1 into 2n plus 1 c. This will give me n plus 1, right? If I'm combining both of them. Hope you got this. Now this becomes your alpha. Let's pick up the beta now. You had given beta is equal to summation k is equal to 0, n minus 1 nck into nck plus 1 divided by k plus 2. Let's multiply numerator and denominator by n plus 1. So you have 1 upon n plus 1 summation k is equal to 0 till n minus 1. Now, again, I'll be combining them. You will have here n c. This will be n minus k into n plus 1 c k plus 2, right? I have combined them. So this will be now equal to 1 upon n plus 1, 1 upon n plus 1 c. This will be combining both of them. You will have n plus 2 over here and n plus 2n plus 1 over here. Okay. Hope you are clear with this. This is your number 2. We got the values, simplified values for alpha and beta, and you are given 5 alpha is equal to 6 beta. You are having 5 alpha is equal to 6 beta. Once again, write down the values for alpha. It is 1 upon n plus 1 into 2n plus 1 c n plus 1. And beta came out to be 1 upon n plus 1 to n plus 1 c n plus 2. Right. So let's use this equation. What I have to find out is n. Okay. Right. So this becomes equal to, if I say beta upon alpha, that will be easier. Beta upon alpha is equal to 5 upon 6. What is beta? 1 by n plus 1 into 2n plus 1 c n plus 2 whole divided by 1 upon n plus 1, 2n plus 1, c n plus 1 is equal to 5 by 6. These will cancel, correct? And then you will have 2n plus 1, c n plus 2 divided by 2n plus 1, c n plus 1 is equal to 5 by 6, right? So now this can be easily simplified, because this will be 2n plus 1 factorial divided by n plus 2 and 2n plus 1 minus n minus 2 factorial. Whole thing divided by 2n plus 1 factorial divided by n plus 1 factorial. 2n plus 1 minus n minus 1 factorial is equal to 5 by 6. These two will cancel out, and you will have n plus 1 factorial n factorial divided by n plus 2 n plus 1 factorial. This will be n minus 1 factorial. This will cancel, and this will cancel. This was equal to 5 by 6. You will have 6n is equal to 5n plus 2. You will have n is equal to 10. That's the value for n. Hope you're clear with this. This is the answer to the question. Hope you're clear with this. Now let's move to the next question, number 25. Question number 26, in an examination of mathematics paper, there are 20 questions of equal marks, and the question paper is divided into 3 sections A, B, C. A student is required to attempt 15 questions, taking at least 4 questions from each section. If section A has 8, B has 6, C has 6 questions, then the total number of ways a student can select those 15 questions is, first thing, there are 3 sections, and it is said that 4 questions has to be attempted from each. That makes a total of 12 questions. How many questions are remaining? 3. Now they have to be selected like this. So it can be done like one is selected from all, or you select 2 from here, 1 from here, and none from here. Similarly, it can be 2 from here, none from here, or 1 from here, or it can be all the 3 will be selected from the first one, right? So this is the possibility. This is fixed, 4, 4, 4, this is fixed, and these are the rest of the possibilities. Now let's check how many ways it can be done. Total ways will be given by, see, from the A section, you are selecting 5, okay, and C 5, and B5, this is for A, this is for B, and this is for C section. So from A, you are selecting 5, B, you are selecting 5, and C also you are selecting 5. Plus, from A, you are selecting 6, from B, you are selecting 4, and let's see, from B, you are selecting 5. And from C, you are selecting 4. Okay, now this can be done like either from B you're selecting or C you're selecting. So this will be multiplied by 2. This can be done in 2 ways. Now, you select 5 from A, 6 from B, and 4 from C, right? Again, this can be done in 2 ways. Like you'd select all the 6 from C and 4 from B. Same thing. Now, next, when you select 4 questions from A section, 6 questions from the B section, and 5 questions from the C section. Again, this can be done in 2 ways. Now 8C, this is 7, 6C, 4, 6C4. These are the total possible ways. And now let's see, this gives me 8C5. This is 8 factorial, 5 factorial, 3 factorial. This is 8, 7, 6 upon 6. That's 56 into this will be 6 into this will be 6. Okay, this gives me 2016. And similarly over here, this will give me 28 into 6 into 15 into 2, which is 5040. This gives me 56, 15 into 2, 56, 15 into 2 into 1. Okay, because this gives me 1. So this is a total of 16, 8, 0. This is 8C4. 8C4, it gives me 8, 7, 6, 5, 4, 3, 2. This cancels and this at 2, so 70. Multiply 6, multiply 2. This gives me 840. And this is 8 into 15 into 15. That is equal to 1800. So adding all of them, you will get a total of 11376. So this is the answer to the question. These are the total possible ways. Hope you're clear with this. Let's move to the next question, number 27. The number of symmetric relations defined on this set which are not reflexive is. So total number of relation, both symmetric and reflexive, is given by total number of relation both symmetric and reflexive is given by 2 raised to power n square minus m upon 2 minus n upon 2. Okay, so the total number of symmetric relations of symmetric relations is 2 raised to power n square plus n upon 2. Then the number of symmetric relations which are not reflexive will be given by symmetric relations which are not reflexive. This is given by 2 raised to power n into n plus 1 upon 2 minus 2 raised to power n into n minus 1 upon 2. And here in this case, the number of symmetric relations on the set 1, 2, 3, 4. That means you are having 4 elements in this. This will be given by 2 into 4 into 5 upon 2 minus 2 into 4 into 3 upon 2. This will be 2 power 10, 2 power 6, 1024 minus 64. This is 960. So this is the answer to the question. Hope you're clear with this. Let's move to the next question then. Question number 28. The number of real solutions for this equation is equal to. Let's write down the equation first. You have x into x square plus 3 mod of x 5. This is actually misprinted a bit. Should have been like this. X minus 1 plus 6 x minus 2 is equal to 0. So that means x is equal to 0, or this expression is equal to 0. So here, this is positive, this is positive, this is positive, and this is positive. All the terms are positive, are except at x is equal to 0. Right? So there is no value of x which is satisfying this equation. Only solution possible is x is equal to 0, because everything rest will give you a positive value only. So that means only one solution is there. Hope you're clear with this. Next is question number 29. The area of the region enclosed by this parabola and this line and the positive coordinate axis is. Let's make the figure to understand this. So this is your particular graph. This is the equation of your parabola. And this one represents, this curve represents your parabola, and this is your line. This one is your line, x minus 2y plus 4 is equal to 0, or x is equal to 2y minus 4. And this is your parabola. Let's find out the point of intersection of this parabola and this line. So this will be y minus 2 whole square to y minus 4 minus 1, which is minus 5, y square plus 4 minus 4y is equal to 2y minus 5, or you have y square minus 6y plus 9 is equal to 0. This is y minus 3 whole square. This gives me y is equal to 3. And when y is equal to 3, you will find out the corresponding value of x will come out to be 2. So this is the point of intersection. This particular one is the point of intersection of the parabola and the line. This line is cutting your y-axis at the point 0, 2. See, when you put x is equal to 0, y will become equal to 2, obviously. And this will be the point. This particular point will be this. Wait. This point. This is 0, 3. So that means in order to find, this is the shaded area, is the region that area of the region that I need to find out according to the question. So area, required area, I'll be taking with respect to y-axis. So this area will be given by limit 0 to 3 x dy minus area of this triangle. Look over here. So I'll be subtracting this triangle from this entire, from this entire area. I'll be subtracting this area of portion. Okay, so from this total area which is combined, which is undertaken by the parabola with respect to the y-axis, I'll be subtracting this particular area. Hope you're clear with this. Let's go to do this. Okay, so now x is given by the equation of the parabola was y minus 2 square is equal to x minus 1. So you will have x is equal to y minus 2 whole square plus 1. This will give me 0 to 3 y minus 2 whole square plus 1 into dy minus area of the triangle, half into base into height. This will be given by, let's open, y square plus 4 plus 5, it will be minus 4y into dy, limit 0 to 3, minus area of the triangle. So see, area of the triangle, the base is 1 and the height is 3. this will be y cubed by 3 plus 5y minus 2y squared. 3, 0 minus 3 by 2. Right? So this will be 9 plus 15 minus 6. 4 2s are 12 and minus 3 by 2. This will be 12 minus 3 by 2. This will be equal to 24. There are two mistakes I have done. This is 2y squared. It should have been 9 into 2. This should have been 18. So, and one more thing. This thing, it was like, let's take this. This distance was 2, not 3. So it should have been 2 and it should have been 2 upon 2, or this should have been 1. Let's do this again. So this will be 24 minus 19, that is equal to 5. So this is the answer to the question. 5 is the answer. Hope you're clear with this. And let's move to the last question of this paper, question number 30. So simple question, variance of this data is. Very simple question indeed. Let's see, hope it turns out to be that simple only. So you have to find out the variance of the data. This is the data which is given to you, xi, and this is your frequency. Let's go for this. First of all, variance is given by 1 upon n summation of fi xi square minus x bar, which is actually your mean whole square. Right? So I need to find out the n. Let's make the table for this. First, you are having xi 0, 1, 5, 0, 1, 5, 6, 10, 12, 0, 1, 5, 6, 10, 12, and 17. Let's write down the corresponding frequency. Fi is given as 3, 2, 3, 2, 6, 3, 3. And corresponding FIXI, let's multiply 0, 2, 15, 12, 60, 36, and 51. So FIXI square, this will be 0. This will be FIXI square, this will be 2. This will give me FIXI square 75, 72, 600, 432, and 867. Let's find out the total of this. This will be 2048 summation FIXI square, and summation FI is equal to 22. Okay, and also summation FIXI also. This is equal to 176. Now, let's find out the mean. Mean is given by summation FIXI upon summation FI. So this is equal to 176 upon 22. That is equal to 8. Now let's fill all these values in the given formula for the variance. Variance was equal to 1 upon n summation FIXI square minus x bar square. This is 22 and this is 2048 minus 8 square, right? So this comes out to be, on solving, you will do all the calculations, so you will get 93.09096 minus 64. This will give me approximately like 29.0909 something 6, okay, which is approximately equal to 29. So this is the answer to the question, 29. So students, with that, we have completed all the 30 questions of this paper. Hope you understood them well, and don't forget to visit our website www.examsnet.com. Here you will find all the entrance exam question papers with the detailed PDF solutions. A very best of luck for your exams. You must download our app. The link is available in the description box. So students, keep shining, keep rising high. That's all for this paper. A very best of luck.